Yes.
Alright, so here are the instructions over here on the left, and I'm going to open another
Three?
I'm going to open another window so I can do that. How do I open another window?
Right. Yeah.
And I'm going to go grab one.
We had a dirty casserole.
Off the blackboard. I'm going to go grab one off the blackboard. Okay, who's wrong? Let's go to yellow, flower stage. There's one. Control it. Alright, there's Troy's data.
To the right wall.
Say it again.
Just the right wall.
Move this up. Back.
No,
Huh?
click where you were, but instead of hitting the top, hit the wall. The side of the desktop.
Okay.
Okay.
Alright, here's Troy's data. There's his graphs. And what we're going to do is we're going to follow these instructions here and add the model to that same spreadsheet. Can I cancel that? So, first of all, he has uncertainty here. I'm going to move that over somewhere else. Does anybody know why I don't have the thing at the bottom I can slide over? I have to maximize it. What?
Double click
Oh, here. I'm going to move these values over here somewhere. And same for the phase angle uncertainty. Good thing over there. Nothing wrong with them. I just don't. I'm going to use them later. I don't need them right now. Now, what I'm going to do is I'm going to insert another blank column. I'm going to insert a blank column between the amplitude ratio column and the phase angle column. I'm going to insert two blank columns there. There's already one, so I'm going to insert another one. So I've got two there. All his data here is in A and B. There's a 4 down there. We can delete that. He doesn't have any data for it. And then he's got data over here in E and some other somewhere else. Leaving C and D blank for now. I'm going to go over here to D. And I'm going to make it the same as column A. I don't think I have to do this, but this is the way I do it. Equal A1. And then I'm going to copy that down here. So now I have the frequency column. Now then, in columns G and H, I'm going to put these parameters, K, T0, and tau. Anybody know what K, T0, and tau stand for? Gain. Dead time.
Time constant.
K equals T0 equals just gonna put in some numbers that are just numbers, and I'm gonna go here, find main, okay, find main. Am I going too fast? Oops, you have any questions back there?
Sure.
Is that enough? That's enough.
I'm good.
Okay, so I've done that much. These are only example numbers, the 111 I put in there are just example numbers. Now enter the value of frequency, the values of frequency that you want to have for your model Bode plot. Suggestion they should be a little bit wider than your experimental range. So I'm going to start down here in row 13 for a reason that I don't have any reason for. And I'm going to start at 0.01 because that's low enough. And then I'm going to enter a number of them, each one 50% bigger than the one before. So I'm going to put it equal 1.5 times that. With me? And I'm going to drag this down here, about that far down. And then go one more. Notice that 2.9 is larger than 2. So I go from the lowest, I go from 0.01 down to a number that's a little bit larger than that data point. Alright. Then I'm going to go over here and drag these down here also. So I got that twice. I'm going to delete these zeros. Alright, so I've done that. Then I'm going to copy this formula here into column C. Highlight and copy. Go over here and paste that in here. And I have to look at that formula. You know it says A10 up here. See it says A10. Can you see that, Janessa? And it should say A13. So I'm going to change that 10 to a 13. 10 was an example on that instruction, just because that's where I did it on that instruction. So that should be, instead of 10, 13, then I'm going to drag this on down here. Then, look at this little formula. I'm going to copy this into F over there. Column F right here, paste.
Your T0, you put a 0 for the name. When you defined it, it's a 0, not a O.
Tell me about that. Where?
In the equation,
In the equation, you should have a 0 instead of a letter.
T naught is TO instead of T0.
Right here?
Yeah, you need a 0 because that's how you
That's
define it.
oh, what did I use up here? T0. Oh, okay, so I have to change this to a 0, right? Y'all are so smart. And then this A10 I have to make to A13, just like I did earlier. I figured it out. Then I'm going to drag that down to the same place, down to 27. All right. Now then, now plot these using chart wizard. That's old-fashioned language, but I think we can do it again. I'm going to, these two that were already on this worksheet, I'm going to pull down Excel is so picky, so picky. I have to put a title at the top of every column. If you don't, it just gets really angry. Watch to see if it doesn't do something different this time. Insert chart. I'm glad I did that. That teaches you a lesson. Look at that. Huh? Now I get what I want. Unfortunately, what's wrong with that graph?
They don't match up.
Say it again?
They don't match.
It's not log log. So I need to make it log log. Who said it's not log log?
No, sir.
Excellent. So go over here, format axis, logarithmic, and go up here, format axis, bless you, logarithmic. And now I have a log log. Let me see, I can do, I like a lot of grid lines here. Add minor grid lines, love them. Log log. So, what do you think? Does the model agree with the experiment there? Say, no, no, sure does. Doesn't at all, does it? Oh, well, let's wait just a minute and do the same thing for phase out. Insert. Are we going too fast? Well, you can always watch it. I think I can put that on YouTube, Ken. Scatter. Here. What's wrong with that chart? It's still not log.
It's just single line at this time.
You think I've done this before? Actually, I practiced this morning just to make sure I could do it. Is that log? No. Format axis. Logarithmic. Closed. All right. Notice that the model doesn't agree with the experiment very well. Got any ideas? These values of KT0 and tau are just wrong. So, here's the procedure.
You don't need to put the other axis in log log?
Say it again?
You don't need to put the other axis in log log?
No, not on the phase angle. It's linear. Let me show you something right now while I'm here. If I click on this, right click, and I go down to format axis and say, oh, maximum, vertical axis crosses at maximum axis value. Then what that does is it moves those things way over there instead of having right in the middle of the chart somewhere. And if I click right here and do the same thing, it moves those things up there above the chart so that the chart is entirely free. I also want to have minor grid lines here. And then I'm going to do the same thing over here. To this one, click on that format axis, maximum value, and click over here. Over here, do the same thing, maximum axis value. All right, now then, let me do this. So now I can see these parameters here. All right, first thing I want to do is change the K parameter so that this graph, the model, agrees with the data at low frequency. We do one other thing right quick. I'd like to clean this up. I'd like to make the markers what's built in. I'd like to make them big, and I'd like no line between the two experimental data points. incremental data points. I don't want to line them right now. This one, model, I want no markers and just a line. So the line is the model and the points are the data. And I'm going to adjust K so that the model comes out about right there. Well, that's 0.1, 0.2, 0.3, so why don't I say 0.3? Sweet. Huh? Now, tau, I can vary now. Let me vary tau to a smaller number like 0.1. Is that any better fit? Let me try 10. Is that any better fit? So somewhere in there is a good fit. Let's try 2. Is that any better? Let's try 0.5. How's that?
Getting there.
A little bit larger, 0.7. Hey, sweet. All right, so now, based on the amplitude ratio graph, I have found the value of K and tau that make that fit pretty well. I am not ever going to change that again until I get different data. If I don't do different data, those are golden, not to take anything away from Goldschlager, but those are the numbers I'm going to use from here out to the end of time. You with me? For K and tau. Finished. What about T naught? I look at the other graph to vary T naught. So let me try 0.1 for that. Not better? Oh, and I only, let me read this graph again. I think I'm talking too fast. What do you think? Not going to say, are you?
It's okay, we can slow you down.
Isn't that one done?
Pardon?
I think you got it back.
Yeah.
Did I do it backwards?
Yeah.
Why didn't you tell me earlier?
I did.
Thank you. Boy, it's so nice to have, what do I have, 25? How many students we have in here? There's 16 over here, 26 times 2 is 52 eyes. It's wonderful. Oh, maybe 1 or 2 of you have one eye closed, so be a little bit less than 52. Now then, let me change this axis over here so that the major units are 60 instead of 50. The reason being now I have a line right at 180 degrees. I have a line marked right at 180 degrees. And I want my model to fit only at one place, at minus 180 degrees. So 0.1, 0.2, somewhere between 0.1 and 0.2. 0.2 is too low, 0.1 is too high, so how about right in the middle? Yes?
When you click on the other graph, is that graph going to change after you change all those numbers?
graphs will change when you change those numbers. Now, you wanna know what's neat about the first graph I used? The model doesn't have T0 in its equation anywhere. So I changed T0 and the first one doesn't change. Watch it. I'll change T0 to 700. First one didn't change at all. Second one did. Change T0 to 0.005. First one didn't change at all. Second does. T0 only impacts that. That's why I asked you to use the one on the left first to get K and tau only, and then use the other one to get T0. Good question, thank you. One clap for Michael. I think that's all. Don't go with no. Okay, that says, for this Bode graph, vary K in order to get it to agree at low frequencies. Vary this one to get it to agree near the corner. The corner is up here. So you didn't see me doing that, but I was looking up here more than down here. Say why I just doing. And then vary on the phase angle graph, vary T0. Get it agree at -80 degrees. Save the file, label the graphs, print the graphs. These are the best estimates of your model parameters that your system. Use these values from now on. If you would like, there's a file like this one available on the internet. Sweet.
You can go ahead and save that one and post it on.
Or can you leave it up so we can take a little bit closer look at it?
By the way, click on here. Let me open this. Let me open it in a new window. Anybody see where it is? Still doing it, right? It's downloading. What's it gonna do with it? Open it here. Yeah, there it is. There's an older one. Does the same thing. Actually, would you like me to put this very file in that place so that when you click here, you get it?
Yes, I would love that.
You would, Troy?
I would. Sounds like a great idea.
Should I stop recording now?
What'd you say?
Should I stop recording?
No, don't stop yet. Now there's a section here on optional. It's all in yellow. You can do it if you want to. It's optional. I'm not going to tell you about it. Now let's look at this paragraph right here. For week 8 reports and presentations next week, you are to have these graphs for each of the regions that were assigned for Bode plots. That's either 2 or 3 from each team. Also, for the report and presentation, put all regions on the same graph for amplitude ratio and phase angle. So this is just for one region. Whoever else did a Bode plot in this team, I'd like to have their data and curves all on the same graph, different colors and things like that.
So I gotta put mine on the same graph as that one is?
That's correct.
Okay.
You did sign.
Yes, sir.
And then compare. You can stop recording now.